Okay, so today we'd like to continue with the topics about writing postconditions, complete postconditions for the bank account class. Okay, that's what we want to do. Okay, let's see what we can continue from. Well, ultimately we're going to see 5 versions of the example, but let me just go over very quickly to the last version we left off, and then we'll go from there. Okay, so now let's have a look on the iPad over here. And then let's look at, oh, by the way, so something very important from last lecture. I tried to explain to you, especially when you are given certain O expression in your postcondition in the short, at the runtime, it's a very important process that's automatically done for you called caching process for all the O expression value. It's really important to have that in mind. And then we talk about how you can check it, for simple example. Okay, you can review the lecture from last time. And also, we talk about the various version about using the O expression, right? You have to know exactly what values will be cached in the pre-states. Okay, that's something we covered last time. So now, today, we're going to go on to our bank example. Okay, so now we talk about basically version 1, version 2, and version 3. Version 1, basically, we are lucky. In version number 1, we simply got correct implementation. However, the contract themselves are actually not complete, simply because they only talk about the account that's being changed, not really about the rest of the bank account should be unchanged. That's the problem. Okay, that's version 1, very easy. And version number 2, basically we try to inject an error. So now for version number 2, basically we still have the correct implementation as before, but now we add an extra line which will make the implementation false, wrong. In the sense that, let's say I want to deposit, let's say $100 for Steve. All I expect to see will be 100 should be the balance for Steve afterwards. Let's say I also try to, let's say, update the balance for another account, any other account. Let's say in this case, the first account, to be 100 as well. That's exactly this line of wrong implementation is doing. However, the current postcondition is very weak. It simply cannot catch this particular wrong implementation. Every time, if there's anything wrong with your implementation, but you cannot catch that using postcondition, that means your postcondition is not complete enough. That's exactly the issue we're dealing with. Okay, that's about version 1 and version 2. Any question from last time? Good. Now, version number 3. We are trying to go towards the final version, but it's I can tell you it's not good enough. But we're going to see exactly why it is not good enough. Okay, for version number 3, we are talking about, and by the way, the source code is all available to you. Please do try out. Okay, for version number 3, we still got this particular wrong implementation, the same as before. But now we try to add an extra postcondition over here, right? Let's understand the logic for this postcondition here, because it's a very common pattern for you to have. Okay, so what I would do is I have some new page for you to compare. Okay, so now only focus on version number 1. Okay, version number 2 is basically another way to write it, which I'll also go over with you. Which one to choose is completely up to you. But for the illustration, for the example, we'll do version 1. Okay, let's understand exactly what version 1 is trying to say. And you can see that we are trying to say across, there's across and then universal quantification. And inside the universal quantification, we have an implication over here. Okay, what are we trying to go iterate over? We're trying to iterate over the old version of the accounts. Okay, so number 1 question, most important question, which value will be cached? Accounts, right? It's going to be a reference copy of the account or shallow copy of the account or deep copy in this case. Reference copy, right? Okay, very good. So that means beforehand, I have a runtime that will simply just say, for example, something like this. Implicitly, all accounts is assigned to just the accounts because this is all the value that's bound to the O expression here, okay? Only that one there. Okay, and then let's try to understand the logic over there. We are saying that when you say cursor.item over here, let's try to understand that. Cursor over here, think it this way. You can think about the old accounts is basically pointing to some array over here, and the array in this case we got Steve, also we got Bill, right? Let me just make sure I got their position right. Okay, we got Bill and we got Steve. Okay, we got Bill and also we have Steve. Okay, and this is the current account, right? Okay, and it's simply just going to be a reference copy. Okay, it's going to be assigned to just a reference for that. So that's why you just see an aliasing over here, right, for the accounts array. Let's try to see what we are trying to do here. When you say cursor.item over here, you're basically saying that when I try to follow through the old accounts over here, okay, that's the variable, it's pointing to this particular array. So that means the cursor is going to point to this particular array that's being referred to by old account, right, the one we cached, one by one. Okay, how many iterations do we have in this case? Only 2, right? You only got 2 elements in the array. Okay, so now when you say cursor.item, the first one, when you say cursor.item, for the very first iteration, is going to point to wherever the first account is. Right? That's going to be the first iteration. And then for the second iteration, it's going to point to the second one. Okay, something like that. Okay, cursor.item. But cursor.item is meant to point to an old version of the account. It's meant to, but it may not achieve that. It may not, okay? And then we say that if the old account has the owner, the old account we're looking at, the owner is not the same as the one we are trying to deposit into. For example, if you look at the previous example, we want to deposit into Steve. If the owner we are looking at is not Steve, so what does that mean? The account should remain unchanged, right? So that means over here, let's try to understand. So that means that's antecedent. If the account is not the one we try to change, we got to say something. Otherwise, we don't care. Okay? In this case, that's what implication means. And then over here, let's look at this line here. So we say cursor.item over here. So this is basically the old account that we are talking about, right? And then current is like the current bank account we are talking about. Basically, it's the current after we have done the implementation for the deposit on. Agree? Okay, that's current. The current is basically the post states after executing the deposit on feature. Deposit on implementation. And now, so that's a new version. And for the new version, we simply call this helper query, which we discussed last time, right? You simply say, given the owner, we want to find out what the associated account is. In this case, you can think about this is the old account, old version of that account for that particular owner, and this is a new version for that owner's account, right? We want to say both of them should be the same. That's why we're using tilde over here, right? Any question about the logic over here? So quite many things over here, right? You have to understand what a caching process is, and also you want to understand logic for this cross loop. Okay, any question is now the time to ask, please. Should I take silence? Yes, good. Which last line? You mean the cursor.item? Okay, that line is basically saying the following, okay? So now thinking this way, so we talk about the deposit on feature, right? Think about this. We're trying to talk about this particular feature call. Think about there is a pre-states and there is a post-states. Pre-state is before you try to execute the body of the implementation, and post is afterwards, right? We try to compare 2 versions of the accounts. And the way for you to compare the 2 versions is to use the old keyword. The way you use it, the version number 1 we talk about, you simply say old current over here. Okay, you simply say over here, old accounts over here, right? So that means implicitly in the caching process, there will be a local variable which you don't have to know about it, okay? It's simply just going to point to the same array, okay? Because that's the caching process over here. And then for this particular line, let's have a look at that. You can see this particular line is the consequence of the implication, right? Which means if we know that the antecedent is true, we're going to worry about the consequence, whether that's true or false. And the antecedent over here simply say if the owner for this particular account we are looking at is not the owner that we are looking for. For example, we are trying to deposit into Steve. If the account owner we are currently looking at is Steve, we don't have to worry because it's supposed to be a change. If it's Bill, for example, that means we shouldn't change Bill. In that, we got to do something about it in the consequence. And the consequence over here, back to your original question here, we are talking about something. Let me write it down again. You have cursor.item tilde. Also, you got current dot account of and then n. Okay, we got left hand side, we got right hand side. The left hand side over here is denoting the account in the old version. Why? Because you can see cursor is actually iterating over, as you can see, the way we declare the across. We say across the old accounts, which means whatever cursor is pointing to should be pointing to the old version, right? You can see old account is pointing to this particular array, so that means cursor the item for the very first time is going to point to this particular account, right? And for the second time, it's going to point to this account over here, right? One by one. Okay, good. So also good? Okay. And then the right-hand side over here, we are referring to just the current, which means that's going to be this particular account that we are talking about. However, since we only did a reference copy for the caching, so the current accounts and the old account, they actually point to the same array. So it looked the same. So that also shows this particular post condition may not be so good, but we're going to illustrate that. Guys, are we okay with this? Okay. Now, but maybe hopefully once I try to illustrate why this post condition is very weak, we'll see why. Okay. Now, have a look at version 2. That's more like a bonus for you. Okay. Version 2 is another way to write things. Another way. Okay. If you don't really feel it so comfortable to actually write across the old version of the account, what you could have done would be you can use our interval notation for the across. You can say from the lower of the old accounts until the upper of the old accounts, right? Lower and upper. And then what we can do is we can say old accounts over here, make sure to put in parentheses, and then we can say i.item, right? Just go to that particular index. Okay, the owner, if it is not the same as that, the same logic over here. Just that the way we refer to the old version, in the first version we say cursor the item. In the second version we say old accounts i.item, right? The across notation is crossing different things for both versions. Yes.
So in your second assignment, when you did
Lab 2, you meant?
Yeah.
Yes.
Sorry,
Go ahead if you want to ask about it.
There was a major problem with lower and upper because when you make it empty,
Yeah.
lower is 1, but upper is 0.
Correct. So I would say whenever you're trying to use the interval notation, vertical bar, dot, dot, vertical bar, it's always the best practice to use the lower and the upper, rather than assuming that your lower is going to be 1 and upper will be, something, right?
Yeah. So will the first version will be a better choice?
I would say version 1 and version 2, to me, they are equivalents. Which one to use is up to you. Okay? Absolutely up to you. It just happened that when I make my slides, I chose version number 1. But last year, a student asked me, can I write it this way? I said, yeah, sure, of course you can write it that way. Since we also taught you about how to write interval expression. So that'll be just equivalent way of writing it. I would say try to know both, and then which one to use is completely up to you, right? I guess maybe for some people, maybe the first version is easier to understand. Maybe it's, for some other people, maybe version 2 is easier.
No, because the problem is it will start from 1 to 0. If upper is 0.
Yeah, so what you're trying to say is, what if, let's say, we simply don't have any accounts in the array? Let's say we don't have any accounts in the bank. So that means, let's say, the value for lower and upper here is not so relevant because in the case of, you're talking about special case. Initially, let's say we got empty bank. Empty bank means we got empty array of accounts, right? So now, in the case where lower and upper, right? So you got different possibilities. The lower can be 0, let's say the C convention. And the upper in this case would just be -1. Okay, if lower is 1, then upper will just be 0. But it's just a different starting indices. It's not really relevant to this particular post condition. So that's why I simply use lower and upper over here, right? And when you have empty collection, as we discussed, universal quantification will just be true, right? You cannot find any witness to prove that it's false. Guys, are we okay with both versions here? Okay? Yes?
It's about lab 2. So I noticed we use old,
Yeah.
values change, but for lab 2, we have like a left and right way, and they don't change. Is it necessary to use old in the post condition?
You may, okay, it's a good question. But, you know what, let me answer that maybe either at the end of today or maybe next time. Because I'm going to go over many examples with you today. Hopefully that'll give you some inspiration. Okay, rather than give you directly the answer. Okay, okay, if no question here, we're going to stick to version number 1. Okay, you can feel free to try to recreate the example using version 2. Okay, both versions are important. Let's go back to version number 1. I mean, version number 3 in the code, of course. Now, let's try to see why this is inappropriate, the postcondition, right? Let's try to see why. So let me just clear the page a little bit over here, okay? Let me just make it clean. So now let's exactly follow the runtime behavior for IFO, right? Which is done automatically for you, but we understand what's going on here. Let's do the very first one very carefully, okay? So now, because we know that since we got this particular old expression, so accounts is going to be cached, right? So that means we are going to have the following. So implicitly, IFO is going to create in the pre-states. You can think about right before the body of implementation is executed, we're going to have old ACC, old accounts, right? It's going to just be pointing to this particular array, right? So now caching will just be like an old accounts is just assigned to the accounts, right? Just the value that's going to be cached. Given that, yes. Yes. There was a typo? Sure. Tell me about it.
The one with version 1 and version 2?
Yeah.
What you just had.
Oh, sure. You mean over here?
Yeah, like after implies student, not and.
It should be, let me see here. It should be, should be item, cursor the item, the owner, right? Let me see what I did over there. Give me one moment. Cursor the item, and then account of cursor the item, the, yeah. Thank you. So I think it is typo. Sorry about that. Okay. I think what you meant, what you're really pointing out is over here. Okay. Let me just write it down over here. And this will be cursor dot item dot owner over here. And then this will be cursor dot item dot owner. Thanks. Good. But the code actually on the actual slides actually right. I just created an extra page this morning. So yeah, thanks. So basically over here, what we're trying to say is you're comparing again the old version over here and also in the new version over here. And what you're trying to look for is the current owner name that we're looking for, right? We are looking at. Okay, good. Yeah. All right, let's now go back over here, okay? So now given that this is the actual value we're trying to cache, okay? Let's try to evaluate the post condition over here, right? Let's try that. So now in the pre-states, we know that this is what we are doing, okay? What about the actual implementation? The actual implementation is going to, first of all, is going to deposit onto Steve's account with $100. So that means it's going to change Steve's account from 0 to 100, right? That part is good. And the extra ROM implementation we are injecting over here is also going to deposit into the other account, okay? Just with the same amount, which means mistakenly, let me just make it in pink. We're also going to change Bill's account from 0 to 100, okay? Now, what we really hope for is after this particular ROM implementation, the post condition can actually give us false. That's what we hope for, right? A good post condition should always give you a violation if the implementation is wrong. If this particular post condition is going to give us the violation, okay? Okay, if you think, well, bless you. Actually, it must be no, otherwise we don't have further versions, right? It's gotta be no, right? But let's see why it is not going to give you the right result. So now, let's say we try to evaluate this particular guy here, okay? We evaluate across. Across when the way you try to say old account, you can think of it as simply referring to old ACC, okay? Just this one that we just cached. Now, across this guy here, it's basically the same array that we are talking about, right? So now the new array, current accounts, is just going to be this array. All accounts is also referring to this array. So we are really talking about the same array. So that's pretty much like a case one for the previous study for the array copy, remember? That's why I set it up like that. So it's completely corresponding. But let's see over here. So now let's just see the first, for the very first iteration. For the very first iteration, you can see that, so we got cursor over here. So cursor the item is going to point to the first account over here. Cursor dot item. Okay? It's going to point to that for the very first iteration, right? Cursor the item is really pointing to this particular account. Okay? That's cursor the item. Okay? The one over here. So now, what we want to know, cursor the item, the owner, not equal to n. In this case, n is simply Steve. Would that be true or false? Repeat again? Okay. Cursor the item, as we know, is pointing to this particular account object, right? Who's the owner? Bill. Okay. Bill not equal to the one we are trying to deposit on, which is Steve. Bill is not equal to Steve. Should be true. That means we should worry about the consequence, right? So now, how do we evaluate the consequence? When we evaluate the consequence, let's have a look at that. When I say cursor the item on the left-hand side, right? I'm talking about, again, this particular object over here, right? So now, what about this guy here? I'm going to put it in green. Account of cursor the item, the owner. Okay, this might be the confusing point. One way to think of this is, basically, you can think about account of is like a current dot account of, right? So now, current is talking about this particular current objects. Current dot, and so that means current dot account is referring to just the same array, basically. So that means when you try to execute this particular account of feature, it's just going to look at the same array. It's just the same. Just because the way we cache the array is just a reference copy. So now account of, and then cursor the item, the owner, in this case, will just be Bill. Okay? And then you simply just say, this is a particular array that's new, and then we're going to return the account that's associated with Bill. And it's just the same account object, just the same. So if they're the same objects, is this particular tilde going to be true or false? The same object should be true, right? So that means it will just give us true. However, we hope that it will give us false, because we are not supposed to modify Bill. Bill should stay at balance 0, but it has been incremented wrongly to 100. But now, just the way we did a copy for the old expression was only a reference copy. So it turns out the left-hand side and the right-hand side just refer to the same object. So there's no way for you to see that particular change. So reference copy is simply not strong enough. I can see many puzzling faces. Tell me which part you don't get. Which one? Account of? Okay. But account of basically, account of is actually a feature that we declare on the bank class, right? So basically, given a bank, you want to give an owner name, for example, Bill or Steve, and then you simply return the associated account objects. That's what we do. It's like a helper query. Yeah. Yes. Guys, are we okay with this? Okay, are you sure? Okay. Kind of. That's okay. Maybe try to get a maybe 60%, 70%, and then study the notes and come to me for help. Maybe. Okay. Yeah. Let's see more versions here. So now, actually, we're going to see a contrast. So now, when we move from version 3 to version 4, we want to see if just by modifying just tiny bits of the same post condition, rather than making a reference copy, we want to make a shallow copy. We want to see if this particular change will be captured by the post condition. Let's anticipate. Is it going to? No. Actually, think about the array copies example we did. We say that shallow copy can only tell the difference if you try to make the reassignment at the very first level. But now, when you try to change the balance for the account object, it's beyond the first level. So the only way to do it is by a deep copy. Okay? Let's see that. Okay, now, hopefully a little bit more comfortable now. Okay, clean code. The only thing I modify is this expression here. Accounts.twin. That's the only change, nothing else. Okay? So now we know that it's going to be a shallow copy, so this particular value is going to be cached. You can think about right before the implementation is executed, we got something like, let's say old ACC and T for twin. It's simply assigned to this particular value verbatim, so it's going to be accounts.twin. That's how we cache this particular post condition value, right? So now let's draw it very quickly. So now that means I How do I, what exactly will be cached? We're going to create a new array, right? Good. So that means I got old accounts twin is going to point to a new array over here of size 2, right? 0 and 1. Do I need to go ahead and create more accounts? No, right? Because it's only a twin. That means over here, let me draw it this way. 0 is going to point to over here, okay? And 1 is going to point to, actually no way around. 1 is going to point to here. Okay, 0 and 1. Which means, just give you one example. So O account twin at position 0 is simply assigned to, well, beyond the first level, it's only a reference copy. And B dot accounts at position 0. Okay, that's a shallow copy. Now, let's try to run the same wrong post condition again. Sorry, the same wrong implementation again. Let's try to execute it. So now, if you only do the previous loop, we're going to deposit 100 into Steve's account. The correct part is going to update that to be 100, but the error that we injected is going to also modify the account balance for Bill to 100. That's the mistake we'd like to catch, right? Now let's see why it will not catch it. Let's see. Okay, if we try that over here, for the very first iteration again. You can see again, cursor, let me use a different color, how about that? Cursor, the item for the very first iteration, I want to change that to green maybe. So cursor, the item, first of all, you can see cursor is iterating over this particular array, right? It's iterating over this particular cache value, right? So that means cursor, the item for the very first iteration is simply just going to iterate over the very first account objects, which happens to be aliased to the first account object for the original array, right? Just happens to be. It's a shallow copy, right? So that means cursor, the item, is referring to this particular account object over here, okay? And the owner for that particular account object is Bill. And Bill is not equal to Steve, the one we are trying to change. It's not equal to that, right? So the antecedent is again true. That means we're going to evaluate the consequence over here again. Now let's see if the consequence will be true or false. Let's see. For the left-hand side, cursor the item, well, as we said before, cursor the item is going to point to the first account objects from this particular cache copy, which is the same, just this guy here. What about the right-hand side? The right-hand side, I got account of cursor the item the owner. First of all, what's cursor the item the owner in this case? Bill, thank you. Let's see. Account of, implicitly we are talking about current the account of, right? So if you say current, that means we're looking at this particular original array, right? Which is different array. However, its account of Bill, well, basically the same object over here, because starting from the second level is aliased, reference copy, right? So now the green and the pink are really talking about the same account. So the fact that we actually mistakenly modify 100 here, we cannot see that difference in the old and new copy. So shallow copy is not good enough in this case.
So why do you use false again? Make sure the value.
Sorry, say it again. I don't quite catch your question. You mean the post condition here?
Post condition which is cursor the item dot owner. If it's not equal to n, then the cursor dot item is equal to the account.
We're saying that if the owner of the account we are looking at is not the one we are trying to deposit into, that would mean that particular account must have not been modified. That's what we're trying to do intuitively. Make sense? Yeah, good. Yeah. Okay, so now that is not good. So now we are only basically we're still comparing the same object here between the left-hand side and right-hand side. Now, final version. Okay. That is why I gave you a little bit tip. Whenever you're, well, practically speaking, if you're simply not too sure whether you should use reference copy, twin, or deep twin, always use deep twin. However, in the exam or in the test, we wouldn't be that easy on you. We want to give you something that might be wrong, and then ask you to explain why it is not the case. But I do have some exercise for you at the end, so don't worry. We'll do that together. You're still learning. Yes? The old? Sorry, say it again? It depends on what you put after the old. If you say, okay, again, you can see so far we got 3 versions over here, right, for the old. Okay, this might be a good point to recap. You can either say old accounts, right? Or you can say old accounts dot twin. Or you might say old accounts dot deep twin, right? So these are the 3 versions we've seen so far. Now, IFO somehow take whatever you write after the old keyword verbatim and try to cache that particular expression in the pre-states. In the first version over here, since you only write just the accounts, so they will only cache the accounts, the reference. The second one is going to cache the reference of the shallow copy. In the third version, it's going to cache the reference for the deep copy, right? So for you as a developer, you have to decide what is the most efficient way to specify while still being correct. Sometimes maybe reference copy will be enough, sometimes, but you gotta judge. If you're simply unsure about it, just for passing your labs or project, you can always use deep twin, that's fine. But you're a scientist, right? You should really want to be a little bit more rigorous. Yes?
Can you go back to
The previous version? Yes, I may.
in this previous version, if you modify the is equal method for account, it's less expensive because you don't actually need to twin copy.
You mean if you modify the is equal feature for which class? Account? It doesn't matter. It is not relevant to this. Why? Because remember when, okay, let's say this. The line that's really important is this line here. Where you say cursor the item, tell the account of this one, right? We're basically comparing 2 account objects. But really the issue is, according to the way we cache the value, which is only a shallow copy. In that case, if you follow the shallow copy over here, the account is referring to this particular account. If you follow the original copy of the array, let's say the blue one over here, it is still referring to the same account. So it doesn't matter how you modify the is equal feature. It's just not relevant. It's just the way you actually did the cache simply give you the same copy of the account. So you have no basis for doing the comparison. Okay, maybe think a little bit more. Good. It's a good question though. Good try. Good. So now, final version over here, you can see that after the old keyword, we have something like this. Accounts.deepTwin. Okay? Guys, by the way, I taught this example the first time, summer 2015, the first time. Imagine how I taught it, no iPad. I drew everything on the chalkboard. That's the main motivation to have an iPad, actually. Yeah. Anyway, that was fun to draw it. Okay, so now let's see why the final version here is going to be the correct version to choose. You have no other option for this particular example. Let's see. So now again, we know that since this expression over here is associated with the old keyword, so that's the let's draw it. Number 1, we're going to make a new copy of the array, and beyond the first level, we're going to make a new copy of every account, right? Let's draw that. So that means let me call the accounts. So basically, we got ACC, and then we have accounts.deepTwin, right? Let me just put it this way to be consistent. So old ACC and then deepTwin. Okay, so now, is it going to point to a new array? Yeah, good, thank you. It's going to point to a new array. Create new accounts. Absolutely, recursively, right? Okay, that's okay. It's going to be completely independent object structure. Okay, so now we got one account, another account over here, and then I got owner, I got balance, I got owner, I got balance. The first one is just going to be Bill, and the second one is going to be Steve, and then 0 and 0. That's in the pre-states. That's basically what we're doing over here, right? Okay, in the pre-state we have old account deepTwin is simply assigned to this particular expression over here, accounts dot deepTwin. Good. So now let's say we go ahead and try to execute the wrong implementation. What we'll do is, first of all, we will modify the, okay, again, we're doing the same deposit. We modify Steve's account balance in the correct way, just change it to 100. Let's say, and then we try to go ahead and execute a wrong implementation line there, which means also mistakenly, we're going to modify Bill's account 100 here. You can see why deep copy is valuable in this case. Because whatever you modify on the original copy there, the deep copy is unaffected, right? Completely corresponding to the array copies example we did previously, okay? Now, let's see, for that particular example here, let's try again. Let's say cursor the item, the owner for the very first iteration, right? So now it's iterating over this particular accounts.deepTwin, which means we're talking about this particular reference over here, crossing that. So now when we say cursor the item, right? For the very first time, question for you, cursor the item, is it referring to this particular object or is it referring to this object here? 1 or 2? 2, right? Okay, good. Double checking, good. Cursor the item for the first iteration is really pointing to this particular account, right? Nothing to do with the original copy. And then the owner name should be Bill, and Bill is not the same as Steve, so that means we should worry about the consequence. Now for the consequence over here, let's see this. Cursor the item is referring to this particular account object, all right? Now, what about the pink one I'm going to put here? Account of, okay, let's figure out this. Cursor the item, the owner, in this case, what is that? Bill, right? Okay. And now, because account of the implicit current context object is current, that means I'm talking about the current objects and then its account. In this case, what's the associated account for Bill? Well, this one here. You can see the pink and the green now refer to completely different objects. So now we can compare. So now conceptually, you can think about the green one is the old copy, and the pink one is a new copy. And we are saying that their balance should be the same. Well, basically we're saying the account should be the same. But now you can see that over here, finally, 0 is not the same as 100. So it's going to return false. Yes?
Like, how do we know when to stop with the post condition? Could in the implementation, if this added a new account?
It's a very good question. Yeah, absolutely. It's a very good question. Let's make the following assumption, even though it's implicit. We do have some exercise for you. Implicit, let's say we don't modify the original array by growing it or shrinking it. But we'll get into an exercise where you have to worry about it. Okay? Yeah. Yeah. But for this example, we we have a very constrained context for you just to learn about using the various copies. Yes.
For last line, we compare the content over it, but I think we need to call the comparison object, right?
No, we don't have to because we're only comparing the account objects, right?
But the tail, it means, the tail, it means if
Yes. Yeah. So you're basically talking about this particular tilde, right? Remember, basically tilde goes this way. This object here is account, right? And this is also another account. The tilde we actually call it is equal feature if it's redefined. Indeed, it was, because you can look at the slides. We actually show you for two accounts to be equal, the owner must be the same, also their balance must be the same. We have done that already.
is it possible to assign the deep copy of all accounts in the view area so that, for example, let's say, for some reason we want to expand also the number of accounts.
Yeah, basically your question is a little bit off the topic. Basically you're asking, is it okay to use twin and deep twin in your implementation? The answer is yes, if you find it necessary. But that's a very different topic from what we are talking about over here. What we are talking about over here is if you want to make sure the way you use the old expression combined with how I for runtime catch the values for you is really going to give you a complete postcondition. You got to be careful what you write over here. That's the topic we're talking about. Whether you use twin, reference copy, or deep twin in your implementation is completely up to you, right? It's a different topic. Yeah. Okay, questions? Yes. Oh, good question. So what variables can you refer to in the postcondition? Good. Here's the rule, okay, which I, maybe in the slides, in the common syntax, but since you asked, I can mention. So you can mention the following things in your postcondition. First of all, okay, let me just write it down. Okay, let's say in general, if you got a feature, with maybe some parameters over here, okay, and also let's say let me put a bit better syntax for you. Let's say in general you have a class, okay, foo, for example, and then you have certain, let's say, attributes. So orange means attributes, right? As many attributes as you like, or queries, okay? Okay, I'm going to just put it here. So it can be attributes, and it can be other queries which also return something. Let's say now I declare a feature which has some parameters over here, okay? And also, let's say it also returns something, okay? Now, what can I refer to in the post condition, okay? Number one, you can refer to any of the attributes or queries, number one, okay? Even if they are private, that's okay. Okay, I'll talk about this rule a little bit later, okay? I'm just telling you can do that. Number two, you can also refer to any of the parameters in the post condition. Think in this way, post condition is more like a contract to show the clients. The parameters over here is what the client will pass to you. Of course, these should be part of the contracts. Okay? And then in this case, because it's actually a query green here, so that means you return something, you can also refer to result. In fact, if you're trying to do the post condition for a query, you must mention result. We will have some exercise for you a little bit later. Okay? Hopefully that answers your question. Okay? Oh, now, of course, local variable, you cannot refer to it. Okay? There's also some tricky thing about referring to cursor variable in the across, which I also have one example a little bit later. Okay? Good. Common mistake. Okay, so now that's about this example here. Let's go back to the slides. Okay, again, we have done all the 5 version. This is the ultimate version number 5, where we try to use a deep twin. And you can see that the result, basically, if you try to call this particular deposit on with the wrong implementation, it's going to give you a post-condition violation. That's really good, because that means we're doing something wrong for the supplier internally. But the contract is going to catch that error and tell you, oh, you haven't satisfied the contracts. Hi. Good. Okay, exercise together. All right. Now let's do exercise together. Since we have time this time, okay, let's do an exercise. Okay, try not to look at your slides. Okay, if you got the slides, let's do this exercise together. Okay, good. Now let's consider we're still doing the bank example. Let's consider a different feature. Let's say we're doing the, let's say we're just doing the accounts off, okay? Oh, you know what? This is back to your question over there. What kind of post condition, let's say for merge or concatenates, right? For the merge or concatenates, we are not supposed to modify anything for the attribute, right? That means everything should remain the same. Good? That's exactly the kind of contract you got to write. But now I show you so many versions. You got to choose which one will work. Okay, that's relevant to your question, okay? So now, so how is this relevant to your lab 2? Thinking this way. If you're trying to specify the post condition for the contract, number one thing you got to say, I haven't modified anything to the state of the objects, number one. And then I will relate the return value to something else. Okay, now let's have a look at this. So we have, basically, we're trying to specify this particular account of, which we have been using a lot, right, in the example. Account of is simply just going to take the owner name and then simply going to return just an account objects, right? Not too sure why I have it here. Doesn't matter. Okay. Okay. So now it's going to be a query. Typically, for a query shouldn't modify anything. It should just return something. Okay. For the account of, now I got so many different post conditions for you. Why don't you take just 1 minute to think about it? I want you to go over each one of them. Okay, each one of them. 1, 2, 3, 4, 5, 6. All I need, just a number after 1 minute. Tell me how many of them will be appropriate for as the post condition for account of. Okay, think about it. Just take 1 minute. Which one? Yes, correct. Yes, correct. Sorry, it's not really showing properly. Yes, it's tilde. Yes, it is tilde. It is tilde. The first 3 we use equal sign. The last 3 we use a tilde. So question 1, I just want to know how many of them is appropriate. Number two, for those you don't think that's appropriate, why not? Number two is the one I'm mostly interested in. Number one, yeah, maybe, yeah, but number two is more important. Think about it for a minute, and then we'll go over each one of them. Okay, another 20 seconds. And then we'll go, and then once I know the number, we have some agreements, and we'll go over one by one. Okay? You know what? It could be that all of them are wrong. It could be. Well, all of them are okay, right? Assuming that you don't peek on the slides. Okay, another 10 seconds, and then we'll have your feedback. Okay, now give me a number. How many of them are appropriate? One. Oh, you guys are smart. Yeah, that's good. Okay, good. Which one? The last one. Oh, you also, yeah, too smart. Too smart. Okay, good. Okay, that's okay. In the exam, this might be only 1 mark. And the rest will be 10 marks each, right? That's my logic, okay? Okay, let's look at the first one. First one, okay, it seems like you agree that it is not okay, okay? That's good. Why? Yes, it's too weak. Basically, I'll just explain that verbally. Okay, you can definitely draw the diagram by yourself. Number one over here, basically what's wrong is, basically this will be, I call that trivially true. Because you're only making a reference copy of the original accounts. You're really comparing the account with itself. That's why, okay, trivially true. Now, number two, if you're smart enough, you will say exactly what I want to hear. For number two, why is it not good? Trivially false. Yeah, you guys are smart. Very good. Okay, simply because we're comparing the account array with its shallow copy. Shallow copy is simply going to create a new array regardless, right? Trivially false. Very good. Trivially false. Okay, number three. True false, the same idea, because deep twin also create a new array, right? The array at the first level, just new different objects, okay? Okay, it's also trivially false, okay? Now we get to the more interesting part. Okay, so now for number four, do you think it's trivially true or it depends?
It depends. Let's say you changed it before you checked it.
Really? Well, since we talk about postcondition here, right? So that means what will be cached beforehand will be just the account itself, right? So now basically, I tell you what, it is a little bit logical implication over here. If we know that this guy here is already true, this guy here is already true, that definitely implies this one is also true. Because this one here is a much stronger comparison. We want to see if they are the same objects. If they are the same objects, it doesn't matter how you redefine the is equal, they should be the same. One moment, let me just say that. Yeah. Okay, this guy here simply implies that one. Okay, so again, this is also trivially true. Yes? You know, even if you reassign the, you mean reassign some account or the accounts array?
Reassign accounts in like the whole array, like that whole object.
The whole objects.
Then you all default into your old one. Can you like make it a full array in the sense of that?
You're saying rather than assigning just one single object in the, okay, let me just make sure what, sure. Let me just make sure I understand what you're saying so everybody can learn from that. I might know what you mean. You're talking about for this particular one, okay? Let's say the accounts is pointing to some array over here, okay? And then we know that the old account is just going to be a reference copy, old account. You're trying to say the implementation itself is simply just going to reassign this to a new array. Yes, you can do that. Yes, actually, yeah, you're right. In that way, it depends. I was kind of assuming that you don't have such a scenario. Okay, how about this? I say assuming that assuming accounts is not reassigned. Yeah, let's assume, very good question. Guys, do you see the point here? The point is, if the implementation is so wrong, they simply just change to a new array. In that case, of course, even the shallow copy, even the reference copy can catch that, even that, okay? But let's say we assume it's not the case. So we can carry on with the discussion. Good, it's good, very good observation, I like it, yes. What do you mean? Yeah, exactly. So if you do a deep twin, that means you're creating some completely different structure. Of course. You mean, okay, a little bit confused what you mean, but okay, we are talking about this particular postcondition here, right? Okay. And the deep twin. Yeah, you know what? Let's maybe talk your question offline, and then maybe I'll share a little bit later. Yeah, that'll be better. Yeah, do come to me, talk to me after the class. Good. Okay, now second last one. By the way, we know that this guy is also not good. Okay, for the reason I just talked about. So what about the second last one? So now, trivially true, trivially false, or it depends. It's a shallow copy. Right? Ah, yeah, exactly. If you're only doing, let's say, for example, if you're only trying to reassign the first account, you can catch that. It's only a first level change. If you try to say, I go to the first account, only modify its balance, that means you're going beyond the first level. So it depends. Okay, it's a yes and no. Okay, but it's not good enough, so it's no. Okay, very good. So please make sure you understand every one of them. Okay, that's one also is not good. Okay, let me write it down. Okay, for you. So this guy over here only appropriates if the change is at the first level. At the first level. For example, if you simply try to do, let's say, accounts, for example, at position 1, let's say we do some extra line, dot deposit. Oh, sorry. What I meant to say was like this. Account is simply assigned to a new, I'll just say new accounts. Okay, if you do that kind of change. And you can also refer that to the array copy example, one of the version. Okay. Now, the final line, that should be a good one, right? Okay, good. That one will just do exactly what we expect to see. So that would mean, for example, I don't quite remember exactly what's on your lab number 2. Either you have to write something like this, or we already wrote it for you. I forgot. Okay, you can check. Basically, for every query, you have to say, well, for this particular query, I'm not going to modify any attributes. I'm only going to return something. Okay? Are we good? Now, we got 20 minutes left, which is good. I'm going to talk about something very interesting with you, about writing postcondition. And starting from Monday, we'll talk about design patterns. So that'll be a good start. But now, I would like to draw a very motivating conclusion about, I'll give you 3 examples which I learned from past students' questions, right? So there are 3 common types of postcondition you might think that will work, but they're not going to work. Yes, I'm going to switch, yes. Okay, we're going to do, it's not on the slides yet. Okay, I just came up with them this morning. Oh, my battery is low? Oh, thank you. You know what? How low is that? Oh, you'll sleep soon. That's not good. You know what? I tell you what I would do. We got 20 minutes, right? Oh, 15 seconds. Oh, that's fine. 15% is fine. We should be all right. Yeah, we should be all right. Thank you. Good. It would be an issue for 1022 last year because it's like a 2 hours lecture. But now we are fine. Okay, now that's good. First example here. So I have a postcondition here and for the feature. Okay, I make it very simple. Basically, we just want to return either true or false, whether x is positive or not. And now, I want you to tell me whether the postcondition is appropriate or inappropriate. Most likely it will be inappropriate. Otherwise, why bother this discussion, right? Well, if you want to work out the logic like that, okay? So now, why would it not be appropriate? Anyone? No, I don't want fix. Fix is easy. I want rationale why this is inappropriate. Give me a precise scenario where at the runtime it will show very weird behavior. I tell you what, this is number one misconception about writing postcondition. Yes? Okay, let's try. What if x is 0, right? Yeah, basically, let's try that, right? Well, first of all, the postcondition should only fail if you have done something wrong with your implementation, right? Okay? Let's say over here, if I say result, let me just give you some implementation here. Result is assigned to x is larger than 0. Let's say I do that, right? So now, as you suggest, what value did you say? 0. Good. So now, let's say we do 0 over here. Let's say we pass 0 over here. So that means result is going to be false. 0 larger than 0 is false, right? And then when we evaluate, okay, up to now, we know that the result is correctly computed to be false. But for the postcondition over here, are we going to fail the postcondition or not? We're going to fail that, right? Well, because 0 larger than 0, that means we're going to have a postcondition violation. That doesn't make sense. I have done the right thing, but you tell me I'm violating the contract. That's not good. That's why I keep saying, whenever you do postcondition for your query, always include the result in the ensure. Questions, or you want to suggest a fix? Sure, let me suggest a fix first, and then how should we fix this? Result implies, it's very good. Actually, I like that. You're suggesting good question. Actually, I like that very much because that's wrong. Wrong in the sense I can carry on further discussion. I like it. Right? Good. Thank you. Okay. Now, why is this not appropriate? Aha, exactly. Which means well, I can do a very easy implementation that will make it always pass. Right? Very good. So now, let's say I simply do something that's crazy. I say result is simply assigned to false. That means when I evaluate the postcondition every time, it doesn't matter what x is, it's kind of irrelevant. So now, false implies anything would just be true. So now, since now you know it's not appropriate, how should we fix it further? Sure. I can simplify that a little bit further. What about if and only if? We have if and only if, yeah, it's there, but you just didn't know it actually looks like this. You can say result if and only if x larger than 0. That's if and only if, right? Well, makes sense, right? Okay, good. So now let's say in the original example here, 0 over here. Okay, so that means 0 larger than 0 will give us false. And if you happen to give us the result, let's say the correct implementation, right? You also have false. False equals false would be true, right? Of course, for this particular wrong implementation, you're just lucky, right? If you try other inputs, you may fail. Okay, guys, are we okay with the first example? First example actually quite interesting. I really like the implies you brought up. It's really good. So, yes.
If you're not assigning the result, how does the result get assigned?
Good. So it's basically the same idea. You can think about result is just like a default local variable or default variable for you to use for the return value. Like what we do in Java. If variable is unassigned, it keeps the default value. For Boolean, it's just false.
So how does it fall? So what is it doing exactly? I didn't quite.
Which one? You mean result equals? Yeah. Basically, we're trying to say whatever the result is, it should be the same as the truthfulness for x larger than 0. If x larger than 0 happens to be true, result must be true. If x larger than 0 happens to be false, the result must be false, right? Yeah.
And I want.
Yeah, yeah.
So what if, let's say, you initially enter a negative number? Okay. Oh, no. Yeah.
Yeah, no, actually, the negative number would be okay, because let's say if you give minus 2, right? If you give minus 2, so minus 2 larger than 0 will be, well, the same idea, right? It's false,
Yeah,
right?
and let's say in the implementation, you multiply by -1.
Yeah, that means, okay, so you're talking about, okay, basically, we are talking about wrong implementation here. You're saying result is simply assigned to, let's say, x multiplied by -1 larger than 0, for example, right? Okay, in this case, since we got minus 2 over here, so minus 2 multiplied by 2, well, basically change the sign. It's going to give us true. So that's a wrong result. So that means when you actually compare this, so true equals false will give you false. So you got a post-condition violation, which is good, right? Yes? Result is assigned. Good question. So what you're asking was, let's say under ensure, if you say x, result is assigned to, that's what you meant, right? Good. I'll be very excited if you write that in the lab test, because your code wouldn't even compile. Okay? The reason is, assignments is only an instruction. It's not going to return anything. Okay? Never ever do that. Assignment is only for implementation. Okay? Yeah, so equal sign. Okay. Guys, any more questions about this first exercise? Okay, I got 2 more. Okay, good. We're still on track. Number 2, this one is a little bit more complicated, but this is relevant to what Ken you just raised during the example. But let's try to just see what I have here. I can tell you that what I have over here is correct, but it may not be complete. Okay? This one requires a little bit more thinking. Okay? I'll go over that with you, what do we have. So let's say we have an attribute called A, which is an array of integer, right? I have a feature, a command, let's say change at. So similar to what we did before for the example, right? We want to change at position I. Let's say we got a precondition already. I is going to be a valid index, so that's not an issue here. Okay? So I is going to be some valid index, and V is the value we want to change over at index I, let's say. So now let's read the ensure together. I'm basically trying to combine 2 things together, right? Overall, you can see there, well, first of all, there's a universal quantification inside which we got a conjunction, right? So we are across A dot lower until A dot upper is J. Okay, and then we are saying that, basically thinking this way, right? If this is the array A, and then we are trying to change, let's say, index I to be value V. And then we have this particular J value over here, okay, J. We're saying that if J happens to be the same as I, that means A at that particular position should just be V, right? That's the case of change. What about the rest of the array? Well, that's the second part. We say that if J.item is not equal to I, for example, you can see this, if J happens to be over here, it's not the same, oh, that's not very good drawing. If J happens to be over here, J is not the same as I. That means that part over there should remain the same, right? That means over here, this should be the same as the old version of J. Are we comfortable with what we have got so far? Let's say this is what you are given. I can tell you it compiles, and it has no errors inside. But now we want to know whether that's complete or not. You got questions? We got answer. Okay, you have answer? Let's wait a little bit. Okay, yeah. This one is also very common. That one is actually, this one is much more difficult to spot, of course. You got question or you got answer? Answer, wait a moment. Wait a moment. Okay, hopefully everybody is clear about what the question is. Okay. Okay, let me go ahead with your answer first.
Is it that the function is equal?
No, that's not the issue. I tell you why. Because over here, Because it's an array of integer. Integer is expanded type. You got a question? You got answer. Got answer? Oh, no, one moment. Anybody else want to try? You know, I just want to see if you guys are very active. I really like it, but I want to see if anyone else would like to try, right? Otherwise, I might get complain, right? Anyone want to try? It's incomplete, I can tell you. But I want to tell me exactly why it is incomplete. We got time, don't worry.
Is it something to do with the equal sign or?
Nothing to equal sign? Where? Which equal sign? This one here? No. That's too low. That's too low level. I'm talking about something very logical. Well, actually, that one's logical, I agree. But, you know, that's more about comparison, right? As I said, nothing wrong with the fragment I gave to you. Nothing wrong with that. That must do a decent job of what it is supposed to do. Let me give you a little bit of hints. A little bit of hints over here. I want you to look at this part over here. If you look at this part, think about what kind of implicit assumption we are making. Look at that part. Oh, one moment. That part there, and also this, that part there, and also this expression over here. That's the hints I will give to you. Maybe that's corresponding to what you're thinking, and then hold it. Okay. If yes, then hold it. If not, you speak out. Is that corresponding to what you're thinking? Then you hold it, yes. Anybody want to try? So my hint is the blue expression I highlight over there on the top, and the one at the bottom there is certain implicit assumption we are making actually, which I said we can assume to be the case in the previous example, but now we can no longer make that assumption. You got answer? You got answer? Nobody else want to try? Okay, why do we take you this time? Yes. Tell me what's wrong. Aha, we're assuming that we didn't really grow or shrink the size of the array, right? So Ken suggests a wrong implementation for us.
You could add an element to the front of the array, and then you could rebase it into.
Yes. Yeah, rebase. Yeah, let's not rebase. Yeah, sure. Absolutely. Rebase. Well, rebase will actually not causing a trouble if it used to be zero based, right? Now let's say the first suggestion. What you're saying is like this. What if we simply say in the implementation there, you do something that's simply correct, you inject one line of error. I simply say a dot force v again, and then a dot count plus 1, which means I will not only change this particular element I'm supposed to change, but also I'm trying to add an extra element over here. So that means a dot count is now becoming larger than old a dot count. Agree? So now a dot upper in this case, what would that be? Well, it's going to be something that's larger, right? Okay, let me make it very precise to you. Let's say we got used to be 1, 2, 3, 4, used to be, and then after the growing we have 5, right? So now a dot upper would just be 5. However, when we say old a dot twin over here is 4, right? Because it's a shallow copy, which means the old a twin is pointing to an array of size 4 only. 1, 2, 3, 4. Now, 5 simply does not exist over here. It's going to be an index out of bound. Well, index contract violation. Okay. So, how do we fix this? That's it. Okay, first of all, do everybody understand what's wrong with this? It's more important. Because the fix is incredibly easy. Okay, what fix should we do? Okay, we can add another post condition, but another question for you. Let's say I suggest the following. I'm pretty sure that's what you're thinking. If I say a dot count is just the same as old a dot count. Okay? Yeah, the same. Now, my question is, there are two possible places you can put this new post condition. Either you can put it before this guy here, place number 1, or you can put it after number 2. What doesn't matter? It could be doesn't matter, right? You know. Oh, you said doesn't matter, right? Okay.
It matters because if you put it after, you could get
Yeah.
didn't want it before.
Because remember, the way contracts are checked is like a sequential execution. You check the first one from top to bottom. So if you put in the second one, you have very good intention over here, but it's not helpful. Because you just get this particular exception first before you even get a chance to check it. So it has to be number one. Okay, you can see many details over here for the example, right? So please do make sure you got everything, every detail here. Okay, are you ready for the final one? We got maybe a few minutes, should be enough. Final one. So this example here, we say all positive, we're defining a query, we're given an array of integers. Let me give you one example. Let's say the array we're given, let's say A, is simply, let's say something like this. So let's say 1, 3, minus 2, let's say 4, okay? And then what we expect to see is some result. Let me use a different color. Result is just going to be a new array with all the positive number, 1, 3, and 4. So 1, 3, and 4. Okay, that's kind of the expected behavior. Now, the current post condition simply do a cross loop and say that whatever result you're trying to return, just that all the numbers are positive. It has good intention. Is it good enough? No. Mm-hmm. Okay, give me a problem, just one.
What if the result only contains one? Because it contains all the positive values.
Yes, true. Actually, even more. Basically, over here, what you're saying this. What if I simply say, let's say hypothetically, let's say I did something very wrong, okay? Very wrong over here. Result is simply referring to, let's say, should be 1, 3, and 4, right? I give you 10, 23, and 46. Totally irrelevant. But they're still all positive. It's still going to satisfy the post condition. Okay? So now, how can we just fix this issue only? I want to say not only that the number is positive, but also they exist in the original array. You said something last time. How do you make sure the element is in the array? So what you can say is, you can say, one fix, you can say not only that it should be positive, but also the A dot has, right? X dot item. Maybe that's what you're thinking, yeah. You don't need to use cross, don't worry. Yeah. Okay, now, with this new fix, is that good enough?
No.
Aha, why? Huh?
You have a size problem.
Not really size problem over here. Not really size. Aha, yes, basically what we're doing over here, yes, or basically, you can think about what we are trying to do over here. You can think in this way. Let's think about, given this particular array, let's say, think about result versus all the positive number in the array. Now let's think a little bit more mathematically, right? So what you have back in 1019 or 1090, think about this as a set. Let's pretend there's no duplicate for the moment, okay? How do I prove two sets are equal? S is a subset of T. T is also a subset of S. Right? If and only if S is a subset of T and T is also a subset of S. Right? So what we are trying to do over here, potentially, you might get some result over here. I'll put it in green over here. The result could be something like this. I only include, let's say, only 1 and 3. So I didn't include all of them, which means basically 1 and 3 over here, all of them are, both of them are positive, and also all of them are actually included in the original array, but that's not good enough, right?
Instead of A dot has, A dot as X dot item equal to
If you know what, if you want to go for the indices, it may not be so good because we didn't specify how if the order can be rearranged. So you don't want to go for indices. Okay, guys, how can we fix this quickly? We got actually we are running over time, right? How about this? We'll start with this example on Monday again. Think about how you can fix it. Okay, we'll start on Monday again, and then we'll do design patterns.